All right, hey everyone. This is Chris Villamay. I'm a technical marketing engineer with NetBrain. Hope everyone's doing well today. Thanks for joining us. So today we're going to present our webinar, Reducing MTTR, Why Adaptive Network Automation is Key. Also joined with me today is Chris Lopez from our technical marketing team, who will be helping to run some live demonstrations in our lab environment. Let's get started. So here we can take a look at what's happening every day in a typical network operations center. For those on the call, this probably feels familiar. How many tickets, how many security events, how many network problems or incidents are happening each week in your environment? The vast majority of these tickets will require a human response. This human intervention is a huge workload and a huge manual effort. When tackling a problem of this scale, what is needed is automation. And of course, the bigger the network, the bigger the need for automation. Historically, network automation has been relegated to tasks such as provisioning and configuration, things that can be planned in advance with a very prescribed set of known tasks that you need to do. This type of automation is built perhaps with weeks of planning so that you can click a button one day and then it's done. For NetOps, with thousands of various events coming in each day, there's no pre-planning available for such automation. So what's needed is a form of NetOps automation that can adapt to any scenario. Within this flood of tasks hitting NetOps, the biggest driver here is incident response. To understand how automation can be applied to the incident response process, first let's take a look at a key performance indicator that's commonly used to track our efforts in reducing incident response resolution times, mean time to repair, or MTTR. So MTTR is defined by 3 operational stages. Detect, typically handled by monitoring event correlation tools. The identify phase, and by identify, here I mean identify the root cause. This phase is typically the most time-consuming phase and hence the biggest variable in MTTR. And finally, there is the fix. The issue is now understood and a fix is available, but what we desire here is to do this as safely and as quickly as possible. So let's look now at an incident response workflow and dive in to identify these opportunities where we can improve, where we can apply automation. So within each of these stages, there are, of course, varying challenges. The incident response process starts with that column on the left, with your monitoring and event correlation systems, ITSMs, SIMs, determining a fault or event has occurred and then notifying the network operations engineers so that they can begin their investigation. First, we have what we refer to as idle time. Under the detect stage, monitoring systems are used to detect that there was an event and now needs an action of investigation to occur. However, often a ticket or alarm will sit idle, potentially for hours, while the impact continues or valuable diagnostic data clears before an engineer is on the scene. So next, an engineer has responded to the event. This is the first response to the incident. There was a lot of manual data collection and analysis that needs to be performed in order to understand what's going on. Every ticket and every device will need to be checked by people. And this, of course, is a very manual and very time-consuming process. That brings us to the next stage in the workflow, the team response. Knowledge within network operations today is generally very tribal. The complexity of today's network technologies, the multi-vendor platforms, plethora of siloed skill sets. We have specialists in routing and switching, firewalls, SDN, load balancers, and so on. If the first responder can't fix the incident gets escalated. The next line of response will then likely perform the exact same tasks that the first response performed before then going on to do additional troubleshooting tasks to try and diagnose the problem. There's probably an element of collaboration needed across teams as well. NetOps working with service desk, working with security. This can result in inefficient collaboration or finger pointing. These first 3 workflow stages represent the time to identify. Ultimately, this identify stage is the largest time within the MTTR process and hence is the biggest candidate for network automation and where we can save the most time in the drive to reduce MTTR. So we repair the problem in the remediation stage. This stage is relatively less time consuming. Finding the needle in the haystack is the hard part. However, there are risks with the remediation stage. If the fix is rolled out haphazardly or without proper verification that it has resolved the issue, it can cause more problems during the incident response. Here, we introduce a fourth stage, the postmortem of incident response. This postmortem is the review of the lessons learned from the incident. The goal here is to improve going forward, to analyze what we did, and to ask the question, how can we do better next time? So now I'm going to talk about how MTTR reduction can be achieved through automation. Put simply, MTTR reduction can be achieved using two high-level methods. Number one, we apply automation at every stage of the incident response process. And number two, we apply mechanisms to continually improve so that we do not hit the same delays should similar problems occur in the future. So coming back to the incident response framework that we want to automate, this is what it will look like when we apply automation at every stage of the process. The first opportunity for automation is before a human arrives on the scene in the form of triggered automation. Triggered automation kicks in the moment an incident is detected to capture valuable problem data and initiate the first diagnosis. The value here is that we can effectively reduce every first response time to 0. Triggered automation therefore closes that gap between the detection of the fault and the action of investigating. The next opportunity for automation during incident response is with the first engineer. In implementing interactive automation mechanisms, we can assist that first response engineer with guided troubleshooting. For the first engineer, once they respond to the incident and begin the initial triage and investigation, their priority will be to obtain the right data quickly and to perform accurate, efficient analysis. This method typically involves manual command line digging. The goal here is to accelerate this diagnosis using automation, knowing what data to get, retrieving it rapidly, and leveraging that expert know-how to analyze this data is required. To help with escalation, the network automation solution should record collected diagnostics and troubleshooting notes and enable everyone to work on the same problem with the same data. This greatly improves team collaboration, reduces duplication of effort, and helps in active troubleshooting. So when remediating the problem, we desire an automation solution that can automatically push changes and assess the impact. This accelerates the fix and reduces the risk associated with the change. Lastly, and this is very critical to our approach in reducing MTTR continuously over time, is the concept of proactive automation. This proactive automation is effectively capturing those lessons learned from every outage, typically in a post-mortem stage of a troubleshooting incident, and then converting that knowledge into automation earlier on. This improves incident response so that the next time it occurs, it enables us to do better next time. Now let's dig in to see how NetBrain's adaptive automation platform applies these automation concepts to continuously reduce MTTR. NetBrain provides two key technologies for adaptive network automation: the dynamic map for deep visualization of any aspect of your network or data, and the executable runbook for automated diagnostic collection and baseline analysis. A NetBrain response can be triggered at the moment an event is detected. NetBrain's first response will automatically map the problem area, essentially capturing the crime scene, and then automatically execute a predefined diagnosis. Next, when the first engineer arrives on the scene, they can evaluate what's already been done by the system. And they can leverage NetBrain's additional drill-down automation mechanisms to quickly pull in more data, review baselines, and perform historical comparisons to isolate the problem. If escalation is required, all teams can now collaborate using NetBrain's shared view of the network to evaluate findings and share analysis in real time. And during remediation of the problem, NetBrain provides a template-driven change process that includes before and after snapshots of the environment and quick rollback should something go wrong. This reduces the risk and it facilitates quick verification after the change that the problem has indeed been resolved. So ultimately, the goal here is to answer the question, how do we do better next time? To go proactive, teams can leverage those lessons learned from each outage to improve the baseline of what NetBrain analyzes, to share enhanced operational runbooks earlier in the process, essentially shifting more of that workload towards the first engineer response or to the first triggered response. So how does NetBrain provide this adaptive automation? As we know, network incidents and problems are unknown, unpredictable. We do not know what problem we'll face on any given day as a NetOps engineer. With or without network automation, to solve these day-to-day NetOps tasks, engineers will always require configuration, topology, and network telemetry information. These tasks are typically performed using a combination of static documentation, manual device-by-device telemetry gathering, and a hypothesis-based troubleshooting approach to divide and conquer until root cause is isolated. NetBrain discovers your total network and constructs a mathematical data model of the entire network. This includes physical and logical topologies, gathering data and providing detailed views on layer 2, layer 3, MPLS, software-defined networking constructs, and so on. We track, baseline, and analyze thousands of data points across your environment. Items such as CPU or memory performance, BGP peering, QoS, firewall characteristics, and so forth are discovered, documented, and analyzed using NetBrain's powerful AI-guided baseline calculations. The goal of NetBrain's data model is to provide that comprehensive view of your environment and of your network data. This provides the foundation for the flexible adaptive automation needed to solve day-to-day network operations tasks. This in turn powers NetBrain's two key technologies that we mentioned on the previous slide. First, we have the dynamic map, which is used to abstract the entire network, automating network visibility and acting as the user interface for your network automation. The map is used to visualize literally any data about the network that may be useful. Topology data, configuration and design data, baseline data across thousands of data points, even data from a third-party solution, all integrated within NetBrain. The second technology is executable runbook automation. This is used to codify operational knowledge within the organization. As teams resolve each outage, their tribal knowledge grows. That knowledge can be documented in a runbook. And as the name implies, these runbooks are fully executable and are built with simple drag and drop programming. The idea here is to write once, execute anywhere. By doing this, we start to codify that expert knowledge and put it into a tool that anyone can use. It is this combination of NetBrain's data model and flexible automation technologies that enable the adaptive automation. So here's a good time to take a look at this in our lab. So let's go ahead and jump over to Chris Lopez for a quick overview demo of how triggered, interactive, and proactive automation concepts can be applied to incident response using NetBrain's automation platform. Over to you, Chris.
Thanks, Chris. So hi, everyone. I'm going to take us through a quick demonstration of this workflow in the context of a network issue. And we've integrated NetBrain here into our ticketing software. And I'm going to show you what it looks like when automation touches each phase of incident response. First, I want to point out that this ticket, which was created from a network alert, has also triggered NetBrain into action. NetBrain has used information from the ticket to trigger a map and execute a runbook on top of it. And it's put that link back inside of the ticket before anyone was made aware of the problem. I'm going to navigate to the map now. So here, we're going to see that triggered automation is providing a clear view of the problem and a basic diagnosis executed on top of it. And this is a significant part of the identification phase. Triggered automation here has saved a lot of time engineers would otherwise spend achieving the same result with repetitive and time-consuming labor. The next step I want to look at is interactive automation. This is where NetBrain helps engineers troubleshoot, collaborate, and remediate issues by using its map as an interface. We can look at the drill down mechanisms here. In this runbook, we can reference all of the CLI commands that NetBrain has executed automatically, and we can use it to mass execute more commands and review them in the same way. We've also executed some more advanced diagnostics called data views. Data views are script-free automation tasks that execute and visually parse CLI commands across the dynamic map. This one is looking for common indicators of performance issues such as CPU and memory utilization or interface errors. And we can see the results for each device visualized on the map. And this is where NetBrain begins to also automate collaboration. Whoever created this data view can also use it to recommend more drill down actions. Down here, we actually have a pane of recommended actions of more automation tasks that I can execute across my environment, from executing more third-party, pulling third-party data from my monitoring tools directly onto the map, going in, executing different kinds of CLI commands, or pulling in other runbooks for different scenarios. I'm going to go ahead and execute this one. And this is NetBrain executing a separate API call to our monitoring system in order to pull relevant monitoring data per device directly onto the dynamic map. Now, inside of this data view, we also have another recommended action. By now, you should see how senior engineers are empowering junior operators by turning their know-how into data views and offering them as possible next steps. And it looks like this one is recommending that we look at QoS. In addition, if I run all of the recommended actions here and I still need to escalate this issue, then this map becomes a shared point of reference for both the problem area and all of the diagnostics that we've run on top of it, meaning that senior engineers don't need to duplicate any basic procedures to make sure that they were done properly. What we're seeing here is NetBrain, again, just executing a number of CLI commands, parsing them into different variables that it's looking for, and then visualizing that data for us in a human-friendly way. And we can see here that we have found a QoS issue on one of our devices, and this is what we need to remediate in order to solve our business, solve the issue with our business service. So over here, we can see how interactive automation can also be used to push changes. And for that, we have a unique type of runbook for change management. Instead of going through this process device by device and manually, we can actually go ahead and define changes inside of each, define the changes we want to make inside of each of these devices, and then push that directly to each one, not one at a time, but all at once if we want to. This means that we're able to also perform a benchmark before and a benchmark after in order to review whether or not the change has occurred successfully, and then verify whether or not our application still works after the change has been pushed, thus creating a friendlier and more constructive environment to push these changes to without having to roll back. So in this sense, NetBrain helps at all stages of interactive automation, and it also helps with proactive automation. Looking back here, if I wanted to take this automation task that looked at QoS, put it into the runbook that was automatically executed at the beginning, I could do that. And the idea is that we go through multiple iterations of this, find a lot of our common issues, and essentially create a closed loop of automation that can be continually improved across each incident. All right, that's everything on my end. I'm going to pass this back to Chris. All yours.
All right, thanks, Chris. Let me go ahead and share again. All right, everyone, let's go ahead and move on. All right, so again, we're going to take a look now. As you saw previously, that was a perspective of incident response and automation, essentially moving from the moment of the event to resolution. But let's now take a look at the automation strategy from a different perspective, from that of the senior engineer, using the concept of proactive automation. Here I'd like to introduce the concept of shift left, that movement of workload and know-how from the senior or escalation engineer downstream to the first responding engineer, and ultimately downstream further to the automation system itself. Because as you saw in the last demo, and with the interactive automation tasks that Chris ran for us, someone needed to define and create those diagnostic automations. So here we'll need to start not at the fault detection or first response, but instead we'll begin at the conclusion of an incident with the post-mortem stage. During the post-mortem stage, the engineering team reviews what happened, what was done to diagnose and identify root cause, and how that problem was fixed. This process produces the operational knowledge and defined diagnostic procedures that can be used to tackle similar problems in the future. With NetBrain, our operational knowledge is translated into the following automation mechanisms. First, the building or enhancing of an executable runbook with the step-by-step diagnostics made executable with automation. Secondly, the tuning of the NetBrain's baseline thresholds to better inform of deviations when a problem strikes. And finally, the codifying of the operational steps to resolve problems that are seen to recur or repeat, so that these common or well-known problems, they can be more quickly isolated with automation should they happen again. The senior engineer takes the operational knowledge and diagnostic procedures and feeds it back into the NetBrain platform, specifically to the first response and first engineer automation processes. So here is another good time for a demonstration. We'll now illustrate this shift left concept with a series of short demos in our lab. These demonstrations will highlight the benefits of proactive automation and show a practical method to capture, codify, and automate postmortem knowledge. This method is critical to reducing MTTR continuously month after month, year after year. So now I'll hand this back over to you, Chris, for that real-time look at how NetBrain accomplishes this methodology.
Thanks, Chris. So as he was saying, I'm taking the role of an engineer at the end of a troubleshooting scenario. And my goal is to solve this problem and to record and document the steps that we needed to resolve this issue so that if something similar comes up in the future, we can get to the root cause a lot faster. So as a expert engineer, I'm often called in to troubleshoot. I'm going to show what it's like to troubleshoot something manually here. So I'm at the end of this workflow, as I said, and I'm looking at the dependencies of an application experiencing performance issues. And I'm going to go ahead and hop into this router here, video pod, and I'm going to execute some CLI commands that are looking for also for common issues, high CPU usage and interface errors. I'm going to use NetBrain's Smart CLI function, which is also going to allow me to document any results that I have to the runbook here. So inside of this device, I'm going to go ahead and execute show proc CPU to tell me what all the processes are here. And it looks like we don't have anything that's really going to be considered being a high usage here. So I'm going to go ahead and go into show interface just to tell me if there's any kind of basic interface errors, things like that. But there aren't any of those either. You know, there doesn't seem to be any output errors or input errors. And one thing that I'm going to add here is that as a senior engineer, I do have, you know, in this scenario, I do have some network knowledge that's going to tell me, or that I'm also aware of, which is related to our SFP transceivers. Right. In this case, I know that we have a lot of off-brand SFP transceivers that have been causing issues across different business services. So I want to do a quick check for this as well. And it looks like we found the culprit here, right? Like a low power alarm on my transceiver, which is indicating that it should get replaced because it's failing a little bit earlier than the OEM ones were. So I'm going to go ahead and document this inside of NetBrain after I save the map. And we're going to go ahead and also show you how, let's exit this. We're also going to show you how each of these results can also takes the shape of a variable. Just to show you how NetBrain is just parsing this CLI command into different variables, such as port, temperature, voltage, right? For this one specific command. For this, it does this for all of these commands. And this is what NetBrain looks for when it's trying to parse information inside of the more advanced automation tasks. This was the purpose of this first session, which was the expert diagnoses this issue manually. He records the diagnostic steps, but everything that we've done here is manual. We've solved this issue, or we've figured out what we need to, to change about this network to resolve this issue. But this is something that I found because of my experience with the network. Other engineers might not know to check for the transceivers, and I shouldn't need to get called in every time there's a new issue. As I mentioned earlier, NetBrain provides the user the framework to create their own script-free automation, data views. Like you saw in the previous demo, data views mass execute CLI commands and then visualize the results on the dynamic map. And my goal here is to codify knowledge and make it executable, so that way junior operators can solve more problems on their own. So I want to create a data view based on my transceiver check. So that way the next time a similar performance issue comes up, I don't need to personally get involved. Only my automation task does. Now I'm inside of the data view template manager, and creating a data view is as simple as taking those variables that I just identified before and then inserting them inside of the automation task. So if I want to look for show interfaces transceiver, just one moment. So I'm going to go to show interfaces transceiver, and I'll be able to see all the variables that I was just looking at, like current, port, temperature, voltage, and it looked like the optical TX power was the one that was having the issues. So I can go ahead and take TX and RX power and then insert them inside of the data view template. And we can see here other different variables that NetBrain's looking for whenever this data view gets executed. This means that when I turn this on, it's going to execute a number of commands, parse these variables into that information that appears on the links between the devices. So over here, again, I added optical TX and RX power to this data view, and I'm going to make it available to engineers by offering it as a recommended action, like you've seen earlier. So over here, in a new part of the network, we've executed a basic device and interface health check, and transceiver data view template is now a part of the recommended actions here, meaning that I am now assisting the junior operator's workflows. I can go ahead and execute this, and instead of having to go through lines and lines of a command line, NetBrain is simply parsing all of the data and then letting us know if we have any issues. We can see down here that NetBrain has found an issue specifically related to this transceiver data view template on one of these devices. So I'm going to go ahead and check this out real fast. And on a different part of the network, it looks like we had a high power alert here on this switch, meaning that this similar issue has popped up someplace else. One thing I could even do is push this back to the machine and tell it to automatically execute this data view whenever an issue is triggered, and automatically creates a map and runbook. Here, we've seen that the level 1 engineer now has the ability to find the root cause because I've tuned automation and I've been able to execute on the map. But if I wanted to, I could actually get the machine to get to this root cause faster by giving it this data view and telling it to automatically execute it when I do a crime scene capture, just like you saw in the first demo. So here, we're going to be able to see that NetBrain be able to condense this automation from very manual tasks down into automation that anyone can use, down into something that no one even needs to be aware of in order for it to be useful. Automation is very brittle, right? I mean, even if you create automation tasks for one part of your network, it's hard to make it translate to different types, to different areas of the network as well. And that's what we're trying to create here, is something that you can write once and then execute anywhere, because all it's looking for is the expected output of CLI commands. All right, and that's the end. That's the end of what I have to show. I'm going to pass this back off to Chris, and he's gonna wrap this up for us.
All right, thanks, Chris. That's definitely some powerful functionality here. Let me go ahead and grab control. All right, so in summary, as you saw with the first demonstration, by applying triggered automation, interactive automation, and proactive automation concepts, and by increasing automation at every level of incident response workflow, and then with the second series of demonstrations, by adding that proactive automation at each postmortem stage, we have the ability to reduce MTTR continuously over time, to build up our operational knowledge database, essentially acting as a force multiplier for every engineer on the team. And of course, to reduce operational costs associated with network troubleshooting, typically the biggest time consumer within NetOps. And then lastly, it greatly improves team collaboration. My experience, one of the biggest challenges within network operations. So I hope this was helpful for everyone on the call, and we'll go ahead and wrap this up. Thanks again for your time today.